without further ado, we shall go over to Normandy, and Francois and Raphael will take us on a tour of their pilot building.
So this is a simple project. It's the first one that we've made on a full scale after trying out different small walls, different sample walls. So here we decided to build a full-scale building, and the aim here is to try out different building provisions, different details to evaluate the difficulties on the working site and to see how, using the process that we've imagined, to see how we could resolve these different difficulties, and this therefore fed into the buildings in Plymouth and the current working site in Norfolk. So it's about 13 square meters, quite a small building. We tried building with the same materials than those that were used during the lab testing phases. So these come from a quarry that's about 30 kilometers from the site. The plant fibers that we used are flax that we used for the load-bearing cob and ground reed. So they come from very close to the site. So this ground reed was used it was used in the thermal layer. So we also, using this prototype, tried to work with and in collaboration with local companies who already build using cob. They've helped us. We've worked in close partnership with them between the park, Raphael, who designed most of this building, myself, and two companies, two tradespeople who are already training people in building using cob and actually building. We worked together and created this project, so we've collaborated, we tried to give each other feedback, gather information about their experience compared to traditional cob building methods, and improve the process and evaluate the whole building process. So I'm now going to give the floor to Raphael, who will walk you through most of our project. Hello everyone, so I'm going to describe this project to you. So as Francois said, we've got a 13 square meter building on the inside, and as you can see it's quite tall simply because we decided we wanted to try out an upper floor building using CobBauge. So in terms of dimensions, we've got 3 meters wide, 5 meters long, 3 meters high on the lowest wall, and 5 meters high for the highest point and the upper, like the highest wall. So what we wanted to try out was a prototype, and it's not a one type building. We've used different implementation methods, different techniques, different details. So for example, for openings, we've got a very varied set of openings, and I'll walk you through them. For the installation of the roof, we've got a certain specific setup. We used also a wooden structure at the back that I'll show you. We've implemented different services in different ways. So we've built many different things on one building to cover all the different systems that may be used on a modern classical house with modern comfort. So I'm just going to tell you about this east wall. So here we've got an opening for a door. It's quite a traditional door. And here we built the wall into the cob wall, so it's in the middle of the wall. And we've got a cladding on the light earth, so this is strong enough for coming and goings. And this door is quite classic in its style. We've got a lintel that I will show you on the inside, which is made of reinforced cob, and this prevents us from having an apparent wooden lintel that is more traditional. So if we move to the back of the building, so here we've got two types of openings, very different but complementary. So here on the ground floor, we've got an opening that was set on the outside of the building, on the outside of the wall. And this opening, as you can probably guess, isn't embedded into the light earth, which is the external layer. It's too brittle to hold, it's too fragile, so it's attached to the cob on the inside. How did we do this? Well, we inserted wood blocks that go through the wall and are embedded in the cob, and we can then attach the joinery to this. So we've got an interior cladding that allows for that nice framing. It's quite cleaner. For the upper opening, we've got an opening on the inside of the wall, and here we've got a tunnel, so it's on the cob, and it's directly embedded in the cob. So here, to keep this continuity with insulation, on the inside, we've got wood wool, and we've covered this with render to keep the continuity between the joinery and the light earth. What you can see here is that this opening is not very wide, so we've got a simple lintel. You can't see it, but it's similar to the one that was used for the entry door, so it's a lintel made of reinforced cob with some wood. Up here we've got a different lintel, it's not visible either. It's also made using wooden blocks, they're slightly bigger, and this allows to support the entire opening because it's quite wide, 1.5 meters. And this also allowed us to put in a plank of wood that finished the entire opening. So let's now move to the east wall. So this east wall doesn't have any openings, but it does have this wooden structure that you see up here that is covered by cladding. So this wooden structure we wanted to try out to see and understand the different joining between different types of walls. So with a CobBauge wall on the ground floor that goes up to 2.5 meters high, and this wooden structure that's quite classical, and we've got wood wool insulation. And so we had all of this water tightness, waterproofness. We wanted to see the different elements and see how they worked with each other. So waterproofness, airtightness, and all these different elements. So it looks quite simple when you at first glance, but it's quite complex, and it was quite interesting to work on those different aspects. If we now move to the south wall, so for this south wall, so here we tried out a large opening, over 2 meters wide, quite regular proportions for a typical contemporary house. You could even have a 3-meter wide opening if you wanted. Here we used an oak lintel, which is traditional. And it sits both on the cob and the light earth mix to carry the light earth. And then we put in this window on the outside of the wall, on the lintel. And so we had some cob that was sticking out from the light earth. So we screwed these into load-bearing inserts that we embedded in the cob. We could have also screwed the joinery in the cob, but we could have hit some stones. So having these wood inserts makes it easier for the implementation and in setting in of the windows. What you see here, this isn't CobBauge, this isn't the CobBauge technique, this is the render that covers the light earth mix. So this is a lime render that was applied using 2 coats. It's a mix of earth and lime. This is what gives it that color. The soil comes from the area. So here this is a rather traditional render. We've got quite contemporary details, so we've got metal angle profiles here. We've got the bottom bit here that allows us to finish the render towards the plinth. Up here you also have a roof using corrugated steel. So this gives it a rather modern look, even though the carpentry is quite traditional. It's wooden carpentry and roofing. And for the plinth, we've got light concrete with a first interior layer that uses light concrete with expanded shale finish. Then we've got an insulating insulation using aerated concrete and light concrete again on the inside. So why did we have this slightly more complex plinth? Well, we wanted to have the same thermal resistance as the CobBauge wall and have a building that was that had high performances when it came to temperature. I'm going to go inside and I will keep showing you the different details and specificities. So here we're inside the building, inside of the CobBauge building. As you can see, we've got different types of finishes. One render finish. So this is an earth render with some fiber. So you can add some render on top of the cob. That's not a problem. This gives you a clean finish. Here you've got the cob wall in its raw state. We've just reworked it a little bit with a little bit of soil to fill in some cracks. So it's much more raw and gives it showcases the earth. So you can see the different details up here. When I was telling you about the lintels, here you've got the oak lintel as they were set in. So they sit on load distribution inserts, and this allows us to distribute the load of the lintel within the cob. Here we've got the reinforced cob lintel, so quite minimalistic in its appearance. You can't see the lintel. The wood blocks start about 40 centimeters into the cob, cross the cob and end over here. So it's kind of like reinforced concrete. It allows you to distribute the load-bearing strength everywhere. And this means the cob can support this large crossing, this opening. So we've got some oak pieces that are about 5 centimeters wide and tall, so 5 by 5, 3 in the cob and 2 in the light earth, so behind the door that you can't see. So you can see that the door sits directly against the cob. And here, same, so we've got a reinforced cob lintel but covered with a render, a plaster, and on the inside, because the window is on the outside of the wall, we decided to put in some plywood framing cladding around the window to give it a cleaner finish. Regarding the upper floor, so yeah, we put in a top floor, so it sits at 2.5 meters high. We tried out different laying techniques. So we tried different laying techniques, and here the large bit of wood is embedded directly into the cob, So we set it into the cob during the building of the lift. So this piece of wood stabilizes the cob. So it's quite interesting a technique. It just means that you need to coordinate with the formwork. So you put the mix in place, then you dig out, you put in the beam, and then you fill back. So in terms of the joist that you can see here, this one sits on a crossbeam, but on this side we've installed it in two different ways. So during the implementation of the lift, we put in a load distribution insert here, and then we dug out some cob and inserted the joist. So once the cob was dry, this gives you a finish that you could then cover with a render or plaster. And here we've got a wall plate that was screwed onto a load, an insert in the wall, and we've embedded the joists in. So it might be a bit simpler for assembling because then you don't have to dig out cob, but you can see the crossbeam and the wall plate, sorry. So in terms of services, we've got three different systems in place. You've got the electric meter here. So during implementation, we chased out some traces in the wall. We added some conduits into the wall. We were careful not to pinch it and to have wide angles to make sure we could push cables through. So we've got a conduit that goes through the wall and comes to this switch or goes to this outlet or feeds these light bulbs, for example. So it's quite minimalistic, and with this system you can't see the services. We had a second system that we tried out. So here you can see some chases that were dug out, and then we filled it up. So this is easier to cut up different tasks, and once the walls are finished, then you can put in you can add in these different tubes. And then the final one where you put it against the wall and you screw this in on the wall and add it along. I'm just going to tell you about the different lifts. So here we've got a wall where you can see the different lifts we built. So this building is 7 lifts maximum at the highest point. So we built lifts quite traditionally. We used some formwork, the mesh formwork, so that this allowed for drying. But what we did was, because this was the first prototype CobBauge building, we didn't want to take too many risks in the implementation and building of the building. So we built things lift by lift, about 70 centimeters of CobBauge in one lift. We let it dry, then remove the formwork, and then set the formwork again on the next layer and for the next lift. So building time was quite lengthy, over several months. What you can see is that we tried different things out. We filled in some cracks and some holes. So this was really the first prototype. So we learned a lot along the way. And so we put in some sensors, some probes, and I think I'm going to get Francois to tell you about the different measurements that were done during the works and afterwards, the ones that are still being done as we film this video. So there we go. So you can see that this building has many cables. These aren't just electric cables. They're cables for the different labs of the Caen University and the ESITC. So they've put in different probes into the wall, so they were embedded while we were building, and this gives them some information, data on measurements and moisture levels and such. And we've also added a couple other probes. For example, moisture probes, thermocouples that can allow us to measure heat transfer. The probes measure moisture transfer. You've got these little discs on each side of the wall at the same place, and this allows us to measure the heat transfer and thermal transfer performances of the wall. So this allows us to give information about real performance rather than theoretical performances that we tested out in the lab beforehand. So you can also see here that you've got a couple other machines, devices that allow us to evaluate the quality of indoor air, for example. So we measure the temperature, quality of air, CO2, VOC, PM content, and this allows us to evaluate real performance of these CobBauge walls. In the building process, we also tried to evaluate the implementation and laying performances. So Raphael did a lot of work on that to allow us to evaluate the type of tools that were used by companies, the time that each task took, and using this and doing this, evaluate the difference between laying time for a single floor building and a building that had upper floors and the different impacts that may have. So here, building the first layer, where we were all discovering the implementation and the technique. I think it was about 12 hours, like 12 man hours. And then on the last lift of the ground floor, we reduced it back down to about 6 hours because we knew what we were doing. And then once we started building an upper floor, then we had to learn a little bit again. So we moved back up to about eight man hours per square meter. So this information obviously is quite specific to this context. It's a small building with various specificities, difficulties because of the scale that mean that all of this is quite relative. I think that's most of it for this little building and of our little project. We're available should you have any questions regarding our experience. Thank you.